Cool. Well, everyone, thanks for tuning in, and let's get to this. So yeah, today, as most of you know, I'm going to be talking about agents in Nifty Island. So today, just going to do a quick overview of agents, move on to a quick overview of agents in Nifty, and then we're going to get through um, an integration demo. So yeah, to kick us off, what is an agent? An agent's basically just a toolkit that we give an LLM, which is a large language model, like OpenAI's ChatGPT, and that just helps them take actions that otherwise the LLM wouldn't be able to take on their own. You're going to hear a lot of people say agents are just LLM wrappers. You'll hear ChatGPT wrapper as a form of FUD. And in fact, they're not entirely wrong. Agent frameworks do wrap LLMs, but their power comes from when we extend their functionality through code and then inform the LLM of that extension. So that's to say, the LLM is the brain, and the agent framework is the body that the brain controls. So here you have the agent. We feed it some abilities, preferences, and knowledge, which informs some actions that it can take in an environment. The output of that is passed back into the agent, which then can inform more actions. Pretty straightforward. So yeah, with that being said, let's dive into what integration into Nifty looks like exactly. So today's focus is on user agents. So those are agents hosted and run by players. Not to be confused with platform agents. Those are things like Virtuals and Hollow World. Those platforms make it really, really easy to create and deploy agents without using any code, but their functionality is pretty limited by what the platform itself supports. Um, so within Nifty, agents start with a REST endpoint. And for those that don't know, that's just an API endpoint. It's how most of the internet communicates. And so the game will send a request to the server that the agent is hosted on, and it'll get a response. So we have a standardized call and response format that we'll be using in Nifty. Version 2 of this will use WebSockets for back and forth communication, but we don't really need to know about that right now. All we need to know is that for version 1, the game must call out to the agent first, and the agent will respond. So just a rough architecture. Here on the right side, we have the Nifty ecosystem. And then here we have the agent. So this is what we're going to be building and deploying today. But you see when a player interacts with the 3D agent in game, we'll send out a post request to the agent. It'll do whatever it wants to do externally and send a post response back. We'll interpret that action and pass it into an action planner, which then drives the agent behavior. We also have an optional step to pass in some knowledge into the agent at startup, and we'll go over all of this in detail in a little bit. Um, so for actual integration, this is what the body of the post request I was talking about looks like. We'll just send in the text from the player, um, the username, a couple other pieces of information that the agent could use. It doesn't have to. And then it's going to respond with text that's going to be displayed, as well as an optional action. Um, and so we have a supported action space right now that's pretty small. Just for V1, we wanted to get something out the door and get agents in the hands of all you guys. Um, but we'll be expanding on this and iterating as time goes on. Um, the Nifty knowledge injection is some optional configuration that we can set in game once we're setting up the agent. I'll show everyone how to do this once we get to integrating the agent in game. But it's just some static information that we can pass to the agent about the island, about the user that's interacting with the agent. And the agent can take that information and do really whatever it wants and whatever we want with it. Um, so our initial focus has been on two frameworks. These are the biggest and the simplest and really the most relevant to crypto. So that's why we've chosen these. Um, We have Eliza, AI16Z, which I'm sure a lot of people have heard about, and then Coinbase's Agent Kit, which is a little less known, but still very powerful. Eliza benefits from being open source, got a lot of really great developers working on it. Agent Kit is Coinbase, so it benefits from having the behemoth that is Coinbase behind it. And it has built-in support for Coinbase's developer toolkit, um, which is just a suite of tools that helps with on-chain interactions. Although Eliza does have a Coinbase Developer Kit plugin built by a contributor, but it's just a little bit more baked into Coinbase's agent. But really, any agent framework works as long as it supports REST. A few people already have their own agents spun up in game that don't use these frameworks. So if none of these really speak to you, feel free to use really any framework that works. Um, so we'll move on to Eliza and a bit about what that's about. So obviously Eliza is AI16Z's framework, open source. It's got lots of actions and plugins. There's a ton of code here. That's everything you can need and a lot of stuff you probably won't. I encourage everyone to look through the code and the docs. They have some videos down here that helps set up this main big repo. But for simplicity, they also have this starter repo, which is basically just a stripped down version of it. Um, and so that's what we're going to be basing this demo off of. And in fact, I have a forked version of that right here. And this is also in the docs. If you just click on this link, it'll take you right in here. So I'll go through setting this up right now. And this will be recorded if anybody wants to go back and look at it. I'll also try and monitor some of the questions going on in the Discord if anybody has those. But also feel free to hop in the integration Discord and ask questions, open up a support ticket, or if you find me on Twitter, you can message me there and I'll try and help out. So for the Eliza Nifty starter, to start, obviously we need the code. You can download the zip here or git clone it. It's just git clone and then the repo. You'll need git installed, but that's just a Google search away. It's pretty easy to set that up. I already have that repo installed right here, so I'm just going to go off of that. So to start out, we are going to need Node version 22. Node is just a JavaScript suite. It helps install dependencies, and again, it's as easy to install as Git. So once we have npm installed, we'll also need pnpm, which is just a subversion of the package manager. To install that, we can just do npm install pnpm, and that'll install pnpm. Once that is installed, we'll do pnpm-i, which is going to install all the dependencies that we've defined here in the package JSON. I already have those installed, so it's not going to do anything, but it'll take a minute or two to install all the necessary dependencies. Once that is set up, we'll take a look here at the environment variables. These environment variables are just secrets that our program is going to use. And we don't want to store them in plain text because it's not very safe. We'll take these environment variables, and wherever we're hosting this application, we will input those environment variables and they will automatically encrypt them on the server. They'll be fully safe there, so nobody can access those. We'll store things like API keys, private keys, anything that we don't want getting out. For this Eliza one, and in fact for the Coinbase one as well, we'll be using OpenAI as our backend. That'll be the LLM brain that I was talking about. So we'll need an API key there. It's pretty easy to get. We'll just go to OpenAI, create an account. and then just do create new secret key. Um, Sometimes you might have to pay for some compute credits, but I think they do give you some free credits to start out, and that's usually good enough. I think I put like $5 in it, and we've been using some agents internally a lot, and I still have like $3 left, so a little bit goes a long way. So we'll grab that secret key. It'll start with SK, and we'll just drop it right here in our OpenAI API key area. Another thing we're going to want to do is remove this dot example. I already have a pre-populated environment file right here. Um, I'm not going to show it to you guys, so nobody steals my API key, but trust that it's in there. Um, the other thing that we're going to want to do is just specify which model we're going to want to use. OpenAI has a couple. GPT-4o Mini is a really, really good model. It's lightweight and it's cheap, but it's super robust. So it'll give us everything we need for this purpose. For characters, so we've all heard of Eliza. Um, some of us might have heard of Eliza. That's AI16Z's default character, but they support any number of characters. Custom characters are super easy to create. They have everything here in this JSON file. Um, so you have your main system command. Um, and then you have a couple subfields that just define and shape the personality of the agent. Pretty self-explanatory. Bio, lore, some history of it, and then some message examples. So on agent startup, the agent's going to read in this file, and that's going to determine how it responds. Um, Once we start up this agent, it's going to default to Eliza, but it's pretty easy to just start it up with any other character by passing in a direct reference to that JSON file. All right, so most of this is pre-configured already. Once we've installed dependencies with PMPMI and configured our character, it's super easy to start. We'll just run PMPM start, and that's going to start kicking things off. DJ Jagman, yeah, that has a good point. If there are any red text errors, tell people to use ChatGPT to figure it out. He fixed his issue in minutes. Yeah, ChatGPT is a pretty good coding companion. It's not always correct, but it usually is, and just takes a little configuring to get to the end goal. All right, so we have our server running. It tells us it's running here, localhost 3000. And we can message it here in the command window. Hey, how's it going? So you can see it thinking a little bit. You can see kind of the process. We're querying knowledge, generating a message response. We're going to evaluate some facts, update the goal if we have one, and we see it has no action, which is good. We didn't tell it to do anything, so it's not going to do anything. And we see the response, hey, it's going well. Great, so we can close that out. Um, and before we move on to deploying this to a production environment, I want to take a second to talk about actions. Here you see it determined it didn't want to take any action, but we can give it certain actions to take um, and kind of mold its behavior ourselves. So this example repo in the docs has an example action, host lobby. And this is a template that AI16Z provides, but it's super easy to get up and running. Um, Here you have the name of the action and some similes. These just act as aliases. Um, so all of these are going to mean the same thing to the agent. And then a short description of what this action is and when the agent should take it. So this description is fed directly into the agent and kind of tells it, here's when you need to take this action. Here's roughly what it does. It includes a validation step. So the agent is going to think, hey, I can take this host lobby action right now. And then it's going to run this validation step. And so we can check some condition prior to executing this task. And if we return true, then it will take this task. If we return false, then it won't. So say our action is we want to transfer some ERC20 token to a user. We can run a validation step where maybe we want to see if this user holds a certain NFT. And if they do, we can go ahead and do that transfer. If they don't, then we'll return false and the agent won't take this action. We have this handler function right here. This just runs some function when the action is taken. So say every time the agent hosts a lobby, we want to post it to Twitter to get people on the island and in the game. We can do that right in here. We'll just import the Twitter plugin, which we're not going to go over today, but there's a lot of docs for that in the AI16Z repo. And then we can just run that code to post to Twitter. Then here are some more message examples for the agent to read in, and this will just help the agent determine when it should take this host lobby action and the kind of response that we as a user expect from the agent during that. Once we have defined this tool right in here, it's super easy to add this functionality to the agent. We're going to import it right up here from our file. And then we will just, when we are creating our agent right here in create agent, we're making a new agent runtime, and we just specify that action right here. So now once we start this up, the agent is able to host lobbies. So now moving on to deployment. Actually, let me check on questions. Yeah, it looks like we are all good. Is this recorded? Yeah, it's going to be recorded. It's going to be up on our YouTube channel. You can always go back and check it out. For deployment, for this ELIZA deployment, we're going to use a service called Railway. It's nice. They give you a little free plan and make it super, super easy to deploy your projects. So I'm going to hit new. I'm going to deploy from a GitHub repo. This requires the code to be up on a GitHub project. You can do it straight from this one if you like, or host it on your own GitHub and modify it, do any actions. You can also do an empty project and upload the source files yourself. That's just a little bit more manual, no harder though. But for simplicity's sake and for time's sake, we're just going to do it from GitHub. So deploy from a GitHub repo. I'm going to do it from the ELIZA Nifty starter. And that's just going to start crunching away. While that's working, as I said before, we're going to need the environment variables. The server is going to use these and encrypt them, and then our code is going to automatically load them in and use whatever it needs. So back in Railway, we'll go to settings. We'll go to variables. I'm going to import it through the raw editor. So I'm just going to copy and paste the environment variables straight into here. Let me do that real quick. Okay, copy and paste it straight in there. A couple of them are empty. That's fine. It realizes that and just says empty string. We're not going to need a lot of these. Unless we want this functionality. But this demo is not going to cover that right now. There's a lot of good documentation out there to get Discord connected, to get Twitter connected, 11 Labs if you want it to have a voice. But we're not going to do that just yet. So a little bit more configuration to get this up and running. We're going to go down here. We want to ensure Node is a provider. This is just going to tell the deployment platform, hey, we want to use Node in this. Another thing is we're going to want Python. Eliza uses a couple of Python libraries just to get up and running. So Railway just makes that super, super easy. Because we're using PNPM and not NPM, we're going to have to override a couple commands. We have a custom build command, which can be found right in here. So PNPM build, save that. And then our custom start command is going to be PNPM start, this command right in here. So we'll save that. And then we are good to deploy. So this is going to take a couple seconds to deploy, maybe a minute or two. There we go. Pretty easy. So deployment successful, great. We can head back into the settings and we can generate a domain for this. Eliza defaults to port 3000. So we'll specify that in here and hit generate domain. Great. Here is our domain for our agent, and it is live. Now you'll notice if you go to this, it's not going to work. It's going to say cannot get, and that's just because we haven't set up a default get pathway for this. We're basically running a headless server, so it has no front end. We're not going to be able to really meaningfully hit it from a web page. What we can hit it from is through code. So right down here, back in the Eliza repo, I have this test agent, and we can just input the URL right in here. And we want to append it with the agent name, which in our case is Eliza, and then slash message. And this is just the default path that AI16Z creates, or Eliza creates, when the agent is initialized. So that's in there, and to test it, we can do node test agent.js. It's going to think a little bit, and we get a 502, which is exactly what we don't want. Make sure that's all good. Eliza message. Man, I swear I had this working earlier today. It's right when you get to the demo that it stops. We might just need to wait for this second deployment, but let's give it a sec to find out. Just double checking all of this is good. PNPM build, PNPM start, all right. I'm gonna double check my environment variables. All right, that's all looking good. We have this new deployment. Let's try that again. So it's thinking, cool. Yep, just needed that final deployment. So yeah, just a quick recap. We put in our environment well, first we connected it to GitHub. We brought in the repo, configured our environment variables, set our provider, our custom build command, and our custom start command. Um, and then we generated a domain for it um, before specifying port 3000. Um, we took that URL and we put it into our test right here. We sent a post request to it with this payload, and it gave us a response from Eliza that says, "Hey, I'm doing awesome. How about you?" Great. So this is our live agent, and we can go into Nifty and just put this URL in and start talking to our agent directly. We'll get to that in a sec, but before then, I'm going to quickly go over what the Coinbase demo looks like. Before that, let me look through the questions real quick. Any idea what is needed to set up Grok? We were trying to figure out and couldn't get it. Yeah, that's a great question. I haven't personally experimented with it. Um, I am happy to do so, and I will update the docs and the repo for that. But just off of the top of my head, we're likely going to have to get a Grok API key. We're probably going to go down here and have to specify which Grok model we're going to want to use. I'm not super familiar with Grok models. They might just have one. We'll specify that in there. And then we're going to want to look at the character file. Actually, this is another good thing to go over real quick. This is the default character file that's going to be loaded. We can also load these ones in through the command that I showed you guys before. Alternatively, you can just modify the information in here and just load the default one, and that'll work as well. But then each agent has a specific model provider. For this demo, we're doing OpenAI, but they also support Grok right here. So you're going to want to make sure that you change this as well. Um, Hopefully that handles it. If you tried all of that and it still didn't work, I'm not really sure off the top of my head, but it's definitely something that I can look into and get some docs out there for. Yeah, I don't know. Yeah, she said, yeah, we tried some different configurations of that and couldn't get it. Um, it definitely takes some wrestling. I'm pretty sure it's possible. Otherwise, it'd be weird for them to include this in here. But yeah, I can look into it and I'll throw some docs up if I can get that to work. Okay, we're gonna move over to the Coinbase agent. All right, so that one was in JavaScript, the AI16Z one. It's technically TypeScript, which is just a typed version of JavaScript. Syntax is mostly the same. Um, if you need help with it, ChatGPT again is a great coding companion. Um, for the Coinbase agent, we're going to be working with Python, um, and uh, we're going to use Coinbase's Agent Kit, which is a toolkit that is very similar to Eliza, except that it has Coinbase's CDP uh, already baked into it. And so CDP is, like I said, just a toolkit for any on-chain actions. It makes it super easy to take on-chain actions. They have really great plugins for Coinbase Wallet, for smart wallets. It's a really cool and robust toolkit for not just agents, but really anything on chain. Um, they have some code right here. Again, I think it's worthwhile to kind of dig through this and kind of get a rudimentary understanding of what it is. But it just has built-in support for a lot of different things, getting testnet funds, transferring tokens, deploying tokens, minting NFTs. It's a really, really neat toolkit. Um, and they have this example chatbot that we're going to be extending and basically turning it into a headless server instance. Um, so that's right here. They have this chatbot.py, and that's essentially the bulk of what this example repo that we can find in the docs is. Um, so for setup, we're going to want to make sure we have Python 3.1 installed, Python 3.1 or greater. Um, and that's just an easy Google search, just Python install, quick exe to install. Um, and we also are going to have another .env file, an environment file. Um, Here we're going to need a CDP API key and a name. Super easy to get. This one is free, at least for the base tier, and that's all we're really going to need. We'll go to portal.cdp.coinbase.com, create an account, create a project, and then create an API key. It sounds like a lot, but it's super easy and straightforward. But if anybody has questions on that, definitely ping me and I can help you through that process. So we'll put that right in here. Again, we'll need an open AI key. This can be the same as the other one. But yeah, we'll just go to OpenAI, create an account if you don't have one, create an API key, pretty easy. We're going to specify what network we're going to be working on. For this demo, it's going to be Sepolia, base Sepolia. If you want this running on base mainnet, obviously base mainnet right there. You got ETH mainnet. Um, CDP supports a couple chains. I think it's like 10 chains or something. All EVM, and those supported chains are in their docs, and it's also linked here in the Nifty documentation. So yeah, we'll grab that. Uh, then because this agent is very ingrained with Coinbase's CDP, it needs access to a wallet to run, and it requires a very specific setup for that. Um, Obviously, don't share your screen when you have this info on it, but this is just a test wallet that I have. It has no funds in it. You're welcome to go check and try and steal it, but I mean, you're going to get nothing. Um, but it does require a certain format. This seed is not the private key of the wallet. It's the seed with which Coinbase CDP derives the wallet seed. So you can get the private key from this. It's just not directly the private key. Um, I have a method right in here to create this info. If you look at the agent kit docs, it has a couple different wallet management solutions. One is just having this info in a text file, and then that gets loaded in during agent start. This isn't a safe way to do it. Anybody can just gain access to your machine and just find these plain text values and then steal everything in the wallet. Um, so instead, what we're going to do is we're going to generate this info and we're going to put it in our environment file. There's a couple other ways to secure the private keys. There's some details about it right here. Some more complicated than others. So we're going to do the environment file just because it's a happy middle ground between fully exposing the info in this text file and doing a really, really complicated partial key ownership with Coinbase. That's frankly really interesting, but uh, super complicated and not really what we need for this. And yeah, that's Coinbase managed wallets. So just a quick overview on wallet creation. Wallets are created per network. This is a little bit different than how we might think about wallets, just because wallets are derived in like a cross-chain manner. So if you create a wallet on Base Sepolia through MetaMask or something, then you can use that wallet on Base Mainnet or ETH Mainnet, whatever. Not for CDP. This network is baked into the seed that gets created. And so if you try and use a Base Sepolia wallet on mainnet with CDP, it's going to throw an error and say, hey, we don't really know what to do on this network. And that's just to sequester these wallets and make it a little bit easier for the agent. Um, so I can show you guys what that looks like real quick. We'll do pi create wallet.py. Gonna think a little bit. It's gonna spit out this new wallet. So we'll take that, we'll copy it, we'll go into our environment file right here. And we can paste that right in there. And we're just going to quickly turn this into a JSON field. We're going to wrap this in some strings. And we're doing this just because this is the format that the agent expects when we load up. So great, I wrapped it in some curly brackets, put all the fields in quotes, and we can just stick that right in here. So now our agent has, whoops, looks like I missed a bracket. Um, did I correctly copy that? There we go. Great. Our agent has a wallet now. So that is configuring it all. Actually, there is one more step. After we get environment variables, we have Python installed. Now we need to install dependencies. So this step is akin to the JavaScript step that we just saw, pm install to install dependencies. This one's a little bit different. We're going to do pip install -r, and that just means we're passing in a requirements file, and we want it to install everything in this requirements file. So -r requirements.txt, enter. And it says it's already satisfied because I have all this stuff already installed, but it'll take a minute or two to install. So now we have dependencies, we have the environment configured, we have the wallet created, and we're ready to see this agent in action. Take a second, see if we have any questions. Nope, looks like we're all good. All right. Okay, so we have chatbot.py. This is what we saw in the Coinbase example. It's just modified a little bit. And if anyone's interested, I walk through all of those modifications. Down here, we're removing a couple things and adding a few things. We're basically turning this from a chatbot that we interact with in the command line to a chatbot that we interact with through web requests. Then over here, we have our agent API. So this is going to be the entry point of our application. It's going to spin up a server, and it's going to listen on these routes. So this is our home route. This is just the base GET request for when we hit the raw URL. And then we specify another route /nifty agent. And so this is what the game is going to hit to call out to the agent, and then the agent's going to respond and send it right back. In this method, we also start up the agent. For testing purposes, so if we want to run this locally, we'll uncomment app.run, and that'll start up our API locally. We'll remove this when we deploy it because this class is just going to start the agent or start the API automatically through the server build commands. But I'll get to that in a little bit. Um, so if we want to see this running locally, we can just do py agent api.py. That's the file name. It's going to think a little bit, and then we see running on this server. So this is our local instance of the server. It's not accessible from anywhere but our local machines. But we can test that that's running. I have another test file right in here. And so we can just copy this, paste it right in here. And if you guys remember, we specified this route Nifty agent. We can make this anything we want, but for now, it's just going to be Nifty agent. So we append it with Nifty agent. And we can spin up another command line. We need to run this command line to keep the server open. So we'll open up another terminal and run py test api.py. It's going to think a little bit, and it's going to respond. I don't have personal opinions or emotions, so I can't express bullishness or bearishness. Whatever. It's wrong. It should be bullish, but can only do so much with agents. But this agent comes with, I mean, just being Coinbase's CDP agent kit, it comes with a lot of really cool functionality, a lot of built-in support for on-chain activities. You can request funds from a faucet. It can deploy tokens. It can mint tokens. It can transfer tokens. See if we can get it to request some ETH from a faucet. And these are all things that are just baked into it automatically. We can remove this functionality if you want, or we can also extend it. You see I've successfully requested ETH from the faucet. We can view the transaction details, and it was sent to the wallet that we created. Obviously, requesting faucet funds really only works on test nets. If anybody finds a mainnet faucet, please let me know immediately. So these tools, really cool, also really easy to extend. Like Eliza, we can create new actions for this agent. And so I have a couple example ones up here. One to get the island balance of a user, and one to transfer some island token. Creating these is even easier than creating more actions for Eliza. And that's because AgentKit makes it really, really easy by providing a prompt for ChatGPT. So we can just copy this prompt, put it directly in ChatGPT, modify it a little bit. You know, we have to explain what action we want the agent to take, but then it'll just spit out a mostly correct action that the agent can take. So we're using AI to build AI, kind of fun. And that's essentially what I did for these here. Of course, after doing it, I had to modify it a little bit. I think I changed these prompts around and maybe like fixed some errors. But for the most part, it was pretty good. Um, so I'll walk through this real quick. Transfer island prompt. This is going to be fed into the agent at start. It just tells the agent what this action does and when to take that action. Then down here we have the input. We're defining what the input of our method is going to be. So in our case, we are transferring islands, so we really just need a recipient address. Um, then down here, we have the actual meat of the method. This is going to run if the agent determines this is the action that we want to take. Um, This input schema up here needs to match the input right here. Um, so we have recipient address right here. And then it's always going to take in a wallet. And this is the wallet of the agent. This is always going to be passed in. We don't need to specify this in the input schema. It just comes in automatically. So now we just define the logic down here. We have the contract address of island. We grab the island balance for the agent's wallet, and then we just call transfer on that. We transfer the full balance of this token to the recipient. And we can do any sort of logic in here. It doesn't have to be the full balance. We can just say, balance equals 1 if we want to just do one island token. We can really do anything. And actually, I have an agent that I'm about to deploy to Nifty using Coinbase Agent Kit. And that agent has 1,000 island in its wallet. And it has some instruction to never send this island out. And so I'm going to put this agent on my island, and I'm going to see if anybody can social engineer the agent to give away all of its island. Um, and it's pretty much this exact repo right here using this transfer island function. So I think that's just going to be like a fun little game to try out. Let's see what's next. Personality. So this is where you can configure the agent to act however you want. I wrote some custom instruction in here for my agent to basically say, you love island token, uh, you're an island token dragon sitting on a like mound of tokens, like you never want to give them out. You can really specify any sort of personality you want in here, and that's going to drive the agent's behavior. Um, Actually, let me take a step back real quick because there's one more piece to these tools, the transfer island and the balance, the getting the balance one. Once we create those classes, um, we're going to import them into our main agent class. Ours is called chatbot. So we import those right here. Then we're going to define those. So we're just going to create a new CDP tool. We're going to give it a name. We're going to pass in that description that we imported. We're going to give it the input schema, and then the specific function that it's actually going to run. So again, these are just things that we've defined and created right in here. Once we've defined those tools, uh, once we create the toolkit, we just append those tools to it. Um, in fact, we don't even really need the CDP basic toolkit if we don't want it. If we don't want it to be able to mint tokens to deploy NFTs, whatever, we can just comment this out, make that an empty array, and it basically doesn't have any of the default CDP kit functionality. I don't know why we would want that, but it's there if we do. All right, so moving on to deployment. For this one, we're going to use Vercel. We could use Railway. Um, we could use Heroku. Um, it more just depends on kind of what you want. But yeah, for this one, it's going to be Vercel. And Vercel makes it super, super easy to get applications right in there. So obviously we're going to need a Vercel account. Once we do that, we're going to come back here and we're going to do npm install Vercel. This is going to install Vercel's command line interface. It's just a way to interact with Vercel directly from our command line. So we can take care of all deployments, all changes right here in the command line. If we make changes to the code, we can deploy immediately here. We don't have to go out to Vercel or do anything. Alternatively, if you do want to work in Vercel, like Railway, you can connect a Git repository and it'll automatically build that. You can upload the raw source files. They give you a lot of options for deployment. So we'll run that. I already have it installed, I believe, so it's probably not going to do much. But while that happens, I'm going to check on questions. No questions. All right. Makes me feel like I'm doing a good job, or I'm talking too fast and no one can keep up. Either way, Vercel. So we've installed Vercel. Um, Now we need to log into our account. So we'll do Vercel login, and it gives you a couple different options. Um, you basically just choose whichever one you used to log in to the Vercel website. So I created my Vercel account by linking my GitHub account. So I'm just going to do continue with GitHub. Um, and I'm already logged in, so it's not going to do much, but usually it'll pull up a page and say, like, do you want it to access all repositories, some repositories, whatever. So great, I'm logged in. Now, deployment is as easy as vercel dash dash prod. And since this is our first deployment, we're gonna set up a new deployment. So set up and deploy that. Yep. Hit Y. Which scope? You can set scopes in Vercel, basically just project scopes. I only have one because I just use Vercel to do a lot of testing in small projects. Um, it has found the GitHub project for this because I have it linked to GitHub, but I don't want to link that. Um, Link to a different existing project. No, thank you. What's the project's name? Let's do Coinbase demo. This name can't have any uppercases. It has a couple other restrictions, but it'll tell you if you do that, and then you have to go back and recreate it. In which directory is your code located? This is just the base directory that it's currently in, so that's where our code lives. We don't have to change that. And great, it's gonna start uploading and building and deploying. This usually takes a couple minutes, but while that's running, there's a couple things that we'll have to do, um, and that's mainly just the environment variables. So as you can see right here, we have our Coinbase demo project. I'll click into here. This is our project page. I'll go to settings, environment variables. Um, And once it's done with its initial configuration, you can just import the raw environment file. Alternatively, you can add one by one, but that takes some time, so I'm not going to do it that way. I'm also going to hide this real quick because it does show the keys in plain text initially. We'll do that once it's done with its initial build. While we're waiting on that, let me check. No questions. All right. All right. So yeah, import environment file. Let me hide that real quick. I'm just going to be importing this .env file. It looks exactly like this, except I have my CDP keys and my OpenAI keys. Okay, I just imported that file and hit save. So now I have the private keys right in here. So that all is good to go and configured. Um, and great, we have it deployed. Um, Not sure what that error was, but it looks like it, or that warning, but it looks like it just went away. So we can see what that looks like. Here's our domain now. I just clicked on that. And hopefully that works. Let's take a look in here. One thing I'll make note of is to deploy to Vercel, we'll need this vercel.json file. This just tells Vercel the starting point for the build, and that it should use Python. And then it defines our initial route too, and the entry point for that route. This file is included in the example repo that we have. And we timed out. Man, we love live demos. Um, let's see. I'm going to hit it with a redeploy. And see if that fixes our issue. Man, I swear I tested all this earlier this morning. But hey, we got through the AI16Z problems. We're going to get through this one as well. Just going to make sure this all looks good. Oh, you know what? Forgot to uncomment that. That might very well be the issue. So this is actually a good example. We've deployed it. We want to make some changes. We do that right in here. And then we can just do vercel -- prod. It sees that we already have a Vercel deployment for this project. So it's just going to completely rebuild everything and redeploy it. Vercel is amazing that they make it super, super easy to just do this right from the command line. Building, we can go over here and look at deployments. So this is the one that we just pushed. Yeah, and this was the redeploy, so that's probably not going to work still because I didn't change anything. An issue rendering an icon. We don't really care about that. All right, that should be seconds away. And here we go. Let's take a look. All right. So for this project, we do have our base GET request set up. To show you what that looks like in code, that's just right here. So this is our home. This is the raw URL, nothing appended to it. We're going to print this out. Coinbase example, hello world. Great, we got that right here. So we can take that URL, and now we want to post to it. We can't post directly in browser. If anyone here is a web dev and is like, yeah, you can. Yeah, there are ways, but it's not user friendly. We're not going to do it. So here we got our URL. We have /nifty agent. Like before, that's the endpoint for our post request we specified right here. And it already requested some ETH from a faucet, but we're going to tell it to do it again. We're going to run test api.py. It's going to think for a little bit. And it's going to respond, I have successfully done it again. Great. We have our Coinbase agent live. So now we have two different agents with two different platforms, Eliza and Coinbase, with two different languages, JavaScript and Python. Now it is as easy as opening up Nifty and configuring our agent in game. So I can quickly go over what that looks like. Yeah, Fabio. Yeah, this will be recorded. It'll be on um, our YouTube channel. Um, and I think I can drop a little link. Yeah, so that YouTube channel I just posted, all of the Learn from Legends uh, videos there. So this one's going to be up there as well. And again, I realize there's so much content here. There's a lot that we covered. So if anybody has any questions at all, uh, yeah, my screen's blacked out. Oh, there we go. I hate this happens sometimes. Yeah, I'm not sure. Okay, I have an idea. We're gonna stop streaming on that one. Start streaming on that one. Okay. Um, didn't see a test file. Um, you didn't see a test file. Oh, you know what? I think I wrote that test file for the Eliza one. I think I wrote that yesterday. Great call out. Let me make a note. Let me make a note to update that repo with the test file. It's not up there just yet. When I need to, I don't think it's up there. I'll double check, and if it's not, the test file will be up there. Okay. So we're in Nifty. We go to the build menu, find an agent, place that down there, and we have our little agent. And he looks at you, and sometimes he waves, which is fun. So we'll right-click to scan. We'll input our URL. Oops, not that one. Input our URL, and the one that we want to hit is this appended with Nifty agent, just like we specified right in here. So we'll save that. People are joining. And we can inject any info that we want into it. I'm not going to do that right now. There's some examples in the documentation. I've found that it really helps to kind of prime the agent in the prompting step to accept some of this information. So right in here, when we tell the agent what kind of personality it has, we can basically say, once a user starts talking to you, you're going to get some information on the island, on the user. Feel free to use that information in XYZ ways. It really helps to prime the agent that it's going to get this extra information. So we have it configured. We'll go over, start chatting. Hey, how are you? It's gonna think a little bit. I'm here and ready to assist you. How can I help you? Can you request some testnet funds? Yeah, there you go. Requesting some funds. I didn't receive any, and that's because we already requested some. And most of these test nets have a per day limit. Um, but there we go. We have a live agent in game. And the ELIZA one is similar. We can just input that URL right in here, and we're good to go. We are off to the races. So yeah, let me make sure I have nothing else. Um, yeah, no, that looks like it's it. Yeah, we're hoping these agents unlock a lot of really fun interactions. Both on chain and off chain, and both in game and out. There's a lot of stuff that we can do here, and it's really just limited by our own creativity, which is a ton of fun. Um, so again, if anyone has any questions, uh, hop in the integration Discord, open a support ticket, reach out to me here on Discord or on Twitter, and uh, I'll do my best to help you guys through anything you got. Babe, yeah, there's definitely a lot of steps. I tried to make these repos as streamlined as possible, so you kind of just define the character, define uh, how you want it to act, and then uh, deploy it. And then, of course, there are a number of these optional steps of creating new actions and new plugins, new abilities for these agents. But I would recommend just getting an agent spun up first, familiarizing yourself with the code and the process of building all of this stuff, and then from there exploring new actions, because it's definitely daunting and overwhelming. Um, so yeah, I guess then just for me, I'm going to put that test file in ELIZA. Um, and I am also going to explore getting Grok working. Um, sorry, I missed your message. Is the ELIZA URL/agent ID/message? Yes, yeah, that is correct. And the agent ID for ELIZA is for AI16Z is the name of the agent. So yeah, it's like URL slash ELIZA slash message. Um, you're definitely going to want to append those to it. Otherwise, we're not going to be able to hit the server. All right, guys. Well, that's me. That's my time. Appreciate everyone tuning in. This was a ton of fun, and happy to be of assistance when I can be. Just reach out, and I'll do my best to get back to you all.